Okay, today for math we're doing Module 4, Lesson 22. You may have noticed that we skipped Lesson 21. Okay, the last one we did on Thursday was Lesson 20, and we're skipping 21 just because it's easy to combine with the next few lessons. So we're going to skip right ahead to Lesson 4.22, 22, and your learning goal is I can compare the size of the product to the size of the factors. There's some math words there. The first one is product. What is a product? What is a product? Ani? The answer to a multiplication problem. Okay, if we're comparing the size of the product, another way to say that is I can compare the size of the answer to the factors. What's a factor? What's a factor? Sonatin?
The two numbers you start out with.
The two numbers that you're multiplying. When you multiply different numbers together, those numbers are called factors. So we can compare the size of the answer to the size of the starting numbers. Does that make sense? That's what your learning goal pretty much means. Let me ask you a question, guys. If I had a piece of cake, or I had a full cake, and I wanted to give you 4/4 of the cake, how much of the cake would you get?
All of it.
One whole cake, right? Would you get one whole cake? Yeah. Okay. Now, what if, instead of giving you 4/4, I just wanted to give you 3/4 of the cake? Would you get all of the cake? Or would you only get some of the cake? Okay. Oops. Okay. Now, what if I wanted to give you 5/4 of a cake? Would you have one whole cake, some of a cake, or more than one cake?
More than one.
Oh. Okay. So, what did you notice? What happened to the size of the cake in the first one? 4/4 of a cake. Did the cake get bigger, smaller, or stay the same?
Stay the same.
Okay. What if I gave you 3/4 of a cake? Did your cake get smaller, bigger, or stay the same?
Smaller.
If I gave you 5/4 of a cake, did your cake get bigger, smaller, or stay the same?
Bigger.
Interesting. In these three problems, is there a factor that's the same? What factor is the same amongst all three problems? Everyone? 12. You can see we're doing something to 12, doing something to 12, and doing something to 12. Back in the previous slide, was there a common factor? What was the common factor?
One.
Cake. Right? Back in the previous slide, we had 4/4 times a piece of cake, 3/4 times a piece of cake, and 5/4 times a piece of cake. Was one similar in all of them? No. What was similar? Cake. The word cake. Here, what's similar is the number 12, the factor 12. Okay, let's do some multiplication. Can we do 4/4 times 12? What does that equal? Okay. What about 3/4 times 12? Well, that equals to 3 times 12 over 4. And I can see that there's some similar factors, right? Because 12 is the same as 3 times what? 4 over 4. And these are similar factors. So what's 3/4 of 12?
9.
9. Okay. I'm going to box my answers so that it's clear. Okay. Now over here, if I have 5/4 times 12, that's the same as 5 times 12 over 4 times 1. Sure, right? And then, do we have similar factors again? Yeah, because 12 is still 3 times 4 over 4. And so what do we end up with? 5 times 3, which is 15. So in these examples here, in the first example, 4/4 times 12, what happened to the size of the 12? Stayed the same. Okay. What about 3/4 times 12? What happened to the size of the 12? It got smaller. What about 5/4 times 12? What happened to the size of the 12? It got bigger. Huh. Are you noticing any patterns? When I multiply a number by a version of 1, it stays the same. What do you notice about the fraction 3/4? Is it bigger than 1 or smaller than 1?
Smaller.
So my number is getting, so my other factor, which was 12, gets smaller. This factor here, 5/4, is it bigger than 1, equal to 1, or smaller than 1?
Bigger.
So my other factor, what was my other factor, by the way? If one factor is 5/4, what's my other factor? 12. My other factor is going to get bigger. Interesting. In this set of problems, we can see that 1/3, once again, remains the same. That means the other factor, 4/4, 3/4, and 5/4, we call those scaling factors. Everyone write this down, scaling factors. The scaling factor is the one that's going to tell you if the factor that's the same is going to get bigger or smaller. Okay? So look, before we even multiply, let's predict. If I have 4/4 times 1/3, do you think the 4/4, the scaling factor, is going to make 1/3 bigger, smaller, or stay the same? Okay. What about in this next one? 3/4 times 1/3. Do you think 1/3 will get bigger, smaller, or stay the same?
Smaller.
Okay. And what do you predict for the last one? Do you think 5/4 times 1/3, is 5/4, the scaling factor of 5/4, going to make 1/3 bigger, smaller, or stay the same?
Bigger.
Bigger. Okay. This slide reminds us that the scaling factor is the number that scales or changes the size of another number. It would be a good idea to write this definition down in your notes. Does your scaling number always come first? In this example over here, we have 1/2 times 5/5. We have 3/5 times 1/2, and we have 9/5 times 1/2. In our previous examples, our scaling factor always came first. Here I can see that our scaling factor is second, and then first and first. How can I tell then which one our scaling factor will be?